So now, this may be an effect you desire, but it's not really the purpose of this circuit. We have a voltage doubling circuitry. These are all the same value capacitors, 100 microfarad right there. We have a 555 timer in Astable mode right there. 10K, 10K for the charging, and then 10K for the discharging right there. But in any case, we are given pulses to a couple of MOSFETs, N channel and P channel in push-pull configuration. You can see we got positive supply up there, negative supply down there. That is either charging this capacitor or pumping this capacitor's charge into that capacitor. So their voltages add up, and thus you get basically a doubling of the voltage minus a couple of diode drops. But in any case, that's what each one of these pulses is the pump of the charge right there. And then this capacitor is going to discharge over time. They're going to fade. So now, here is the circuit where we have a voltage doubler here. It's being switched with these push-pull MOSFETs because they connect to the supply rails really well. But we need something to set the timing. So we got the 555 timer right there to set the timing. So far we've only looked at the 100 microfarad capacitor though. So there you can see that's a slow pulse right there. But in any case, it sets the high-low pulses there, and it alternates. When we have a high signal, we get a low connection right there, and the capacitor charges right there. When we get a low signal, then we get the positive supply coming here, and it pumps that charge into a storage capacitor, and we have an LED load that is using up that charge. But in case, we effectively get double the voltage, although there are two diodes that drop some of the voltage, so we do fall short of double the voltage. So now, we come back to our voltage doubler circuit, although it's working way too slow to actually be effective. But we do get pulses, which you may like. So there you can see, 100 microfarad capacitor, slow pulses. We should get rapid pulses with the 10 microfarad, and then 10 nanofarad. It should look really steady. So I haven't done this in a long time, but I'm pretty sure that's what it'll look like. And that's stray signals, I think, that are causing that. But yeah, there you can see. We got pretty rapid pulses. And I'll dim the lamp. It'll be a little bit more effective right there. Yeah, so yeah, maybe you'll like that. That's one way you could use the voltage doubler. But the main reason why is we want enough voltage to light two series green LEDs. And again, stray signals are causing it to kind of glow, it looks like. But there you can see, now that we got a capacitor on there, we got probably close to 8.5 volts right there. So now we have the voltage at the output of our voltage doubler. We are switching that capacitor right there to charge and pump it with a couple of MOSFETs in push-pull configuration. They are being controlled by a 555 timer in Astable mode right there. But we're going fast enough. We got a pretty steady voltage right there, enough for the meter to measure 8.4 volts, a little less than 8.5. So what's great about that, if you're not sure what the circuit's doing, the supply voltage, going to the positive supply right there, is 5 volts. So we got more voltage at the output because it's a voltage doubler circuit. But of course, you're not going to get the double the voltage because we have a couple diodes along the way for the main thing. And then the load will affect it a little bit, you know, right there. We got about 9 with no load, but that's mostly due to leakage that can go through the diodes when they don't have to provide power.